All right, in this video, we're going to revisit solving systems of equations, but for conics. This is something that you did with linear equations. We did this with quadratic equations, also in Algebra 2. You probably solved systems of equations in geometry as well a little bit. So the concept is similar. We are going to first revisit substitution, solve one of the equations for the other variable. It happens to be that this one is solved for y, or you could solve for a variable squared. That's a good option as well, and then substitute into the other equation. Here we only have it solved for y, so we want to substitute in just for y in the other equation. So we'll take that first equation, we'll rewrite it as 2x squared plus, even if you don't think it's necessary, highly recommend plugging in using parentheses. And then something else I would always recommend in algebra, it might also help to write out something that's squared twice so that you make sure that you multiply it out correctly. And really the rest of this is a lot of algebraic work. We get 4x squared plus 4x plus 1. Whoops, I'm ahead of the game there. And then the ones will cancel because you could subtract 1 from both sides. So we would end up getting 6x squared plus 4x equals 0. And that's good that it's equal to 0 already because it's quadratic. You can factor out a GCF of 2x. We're left with 3x plus 2. And we get two solutions for x that could work. X is 0 or x is negative 2/3. And then you have to remember anytime you're solving a system of equations, you're not done when you get one of the variables. You need to get both x and y. So once you find x or y, we're going to substitute the value that you found into one of the equations. Now, think about what equation makes sense. Whenever you have substitution, one of the equations is always solved for that opposite variable. So pull that equation down, substitute in your numbers, and notice I separated it with a line down the middle. You want to make sure you put in your solutions the corresponding value. So far I have a solution of 0, 1. I'm going to write it as an xy coordinate. And then if I plug in the negative 2/3, oh my goodness, we get a fraction. So it makes sense. I mean, we started out with a fraction as our x value. So it does make sense that we would get a fraction y value, although that's not necessarily going to be the case because sometimes the number that's in front will cancel out that denominator. So those are our two solutions that would work for that system of equations. And actually, if you wanted to think about what this would look like, this would be an ellipse. It would be larger vertically. And then you'd have your line going through at 2 points. That probably wasn't the best rendition. We are not going to delve into looking at the calculator. It's a little more challenging to plug in this first equation. The lines are easy to plug in, but the ellipse and the hyperbola equations are not as easy. All right, and then our other option algebraically would be elimination. So we're going to take a look at one example using elimination instead. The goal here is to make sure you eliminate the variable that only shows up once. So think about this before you do something that seems to be the easy option. To me, looking at this, I see, okay, it'd be really easy to eliminate the 9x squared. Unfortunately, I notice I have a minus 72x here. So that x showing up more than once in that first equation, that's actually not the variable we want to eliminate. We want to eliminate the y squared. So we're left with a quadratic with x's. So we're going to take our two equations. I like to do this horizontally. I know that some of you are going to probably do this in a more vertical fashion, at least for the first step. And our focus is going to be on the 25 and the negative 15. We want those to cancel. We want the signs to be opposite. So we have to think about what are we going to multiply by for each of these equations to get those to cancel or eliminate? So common multiple of 25 and 15 is 75. So my goal would be to get 75y squared minus 75y squared. I always like to write that first, and I probably should have highlighted that in blue. I think we can see what's going on. So if I want to do that and work backwards, what times 25 is 75? I can multiply my first equation by 3. And then what times negative 15 would give me negative 75? I'll have to multiply that second equation by 5. So we will get 27x squared plus 75y squared, that works, minus 216x equals 243. And then if I multiply the 5 through the bottom equation, we get 45x squared minus 75y squared equals 45. Always make sure to multiply on the other side. Sometimes that gets left out, and then you get some really weird answer that comes out because you didn't remember to do the multiplying here. Now, because the signs are opposite, it maybe made it easier for ourselves. We can add the two equations together, so we get 72x squared. The y squareds cancel or eliminate, that's what we wanted, minus 216x equals, and then 243 plus 45 is 288. Now, at first you're going to look at that and say, oh my goodness, I have to factor. These numbers are huge. But take a look and see, can you divide everything by this number here? Maybe you can, maybe you can't. And if you can't, then you look for something a little smaller. But try that first, because a lot of times the number does go in, that leading coefficient does go into everything. In this case, we would get minus 3x equals negative 4. Oh, sorry, positive 4. And then we'll subtract the 4 from both sides so that we can factor. And you always have lots of options here. I mean, you can use quadratic formula if you're not sure how something factors. If we get rid of that 72, though, this should be a fairly straightforward factoring. X minus 4, x plus 1, and we get x is 4, and x is negative 1, or x is negative 1. Now there's two equations, two options. I'm going to go with the one that has less going on. Neither is solved for x or y, so I'm going to do the one that has less terms, less chances to mess up or make an arithmetic error. So plug each of your x's in, do your work. I did not show a lot of steps here. And you would do 9 times 4 squared, subtract that from 9, that gives you the negative 135, divide out the negative 15, we get 9, and then we're taking the square root. Anytime you take the square root, make sure you do plus or minus the number. So in this case, we're going to get 4, 3, and 4, negative 3 as my first two solutions. The other one, when we go to do this, you end up getting 0, because you'll get 9 minus 15y squared is equal to 9. The 9's cancel. Square root of 0 is still 0, so we only get one solution from that right side. And we end up with 3 solutions here. And this actually would be, if you look at the equations, we have one adding, one subtracting. This would be an ellipse intersecting with a hyperbola, but only at 3 locations. All right, so that takes you through one of each of solving systems. That should give you a good background and refresher to help you with doing the practice for this now.